Back geometry to another section on right triangle trigonometry. This section we are looking at the converse of the Pythagorean theorem. The converse of a logical statement just switches the if part and the then part. So while in the Pythagorean theorem it said if a figure is a right triangle, then it has the relationship a squared plus b squared equals c squared. The converse says if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So, in other words, if a squared plus b squared equals c squared, then it's a right triangle. Okay. As a corollary to that, if it's not exactly equal to, and this is the way this is worded, if the square of the length of the longest side of the triangle, so the way this is worded, c squared equals a squared plus b squared. And you'll see why we're going to want to have the c squared first using the converse in a second, because a corollary to that compares that square of the longest side. If the square of the length of the longest side is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. So if c squared, in other words, is less than a squared plus b squared, then it's an acute triangle. Now, how I want you to picture this is using this same diagram, using those same lengths, a and b, if a is slightly bent inward. So in other words, so this is, we're trying to, when c squared is equal to a squared plus b squared, this is exactly 90 degrees. If this is slightly bent inward, that's slightly bent inward, past where it would be if it was a right angle, then a and b's square are still the same amount as a squared and b squared here, right? If it's the same a and b, but the c, if we're scrunching this in, we're bending this in toward where b is, then c is going to get shorter, and this angle here is going to be smaller than 90 degrees. So c squared is less than a squared plus b squared, then it's an acute triangle. All three of these angles are going to be acute angles. Okay, that it will be an acute angle. And if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths on the other two sides, so if c squared is greater than the triangle is acute. So if c squared is greater than a squared plus b squared. So let's imagine that same a and b from the right triangle, but this time we're going to bend a outward. We're going to bend a outward and keep b and a the same length. Then that would mean that c is going to have to be bigger. C is going to have to be bigger than the c in the picture, and this angle here is going to be an obtuse angle. Triangle is obtuse. Okay, that angle is going to have to be bigger than 90 degrees. So this is going to be true for any triangles where we know a, b, and c. So you can determine the type of triangle. C is the length of the longest side. C squared is greater than a squared plus b squared, it's obtuse. C squared is equal to a squared plus b squared, it's a right triangle. And if c squared is less than a squared plus b squared, it's acute. Remember, to even be a triangle, a plus b has to be bigger than c. So we do want to check that initially just to be sure. So we're not doing any work that we don't have to. So like 14 and 48, that adds up to 62. Yeah, that's definitely bigger than 50. So to see what kind of triangle it is, we're going to square 50. I'll just write this as 14 plus 48 is bigger than 50. Now, 50 squared, take the biggest side, that's our c. So this is a, b, and c. We're going to square all three of these. And when we're deciding which direction this is going to point, I'm going to put a little box here. And then we'll square the 14, we'll square the 48. Let's see what we come up with. So 50 squared is 2,500. Okay, so we got a 2500. 14 squared is 196. And 48 squared, let's clear that, 48 squared is 2304. 2304. So when I add 2304 plus 196, I get exactly 2500. So these were equal. These were equal. This is a right triangle. Okay. When I go and do that with this one, 3 plus 15 is only 18. That's actually less than 20. This is not even a triangle. Not a triangle. Okay, not a triangle. 7, 8, and 9. 7 plus 9 is bigger than, or 7 plus 8 is bigger than 9. So let's try 9 squared compared to 7 squared plus 8 squared. So 9 squared is 81. 7 squared is 49. 8 squared is 64. If I add the 49, and the 64, I get 113. So the 81 is smaller than 113. 81 is smaller than 113. So this is an acute triangle. Acute. Because remember, if that c squared is equal to a squared plus b squared, then it's a right triangle. If c squared is less than a squared plus b squared, it's an acute triangle. If I try the 14, 16, that's 30. That's bigger than 27. 14 plus 16 is bigger than 27. So let's try 27 squared compared to 14 squared plus 16 squared. Remember, always select your biggest side as your c. The other two are a and b. This is c, a, and b. So 27 squared is 729. So 729 compared to, let's try 14 squared. And when the numbers get big, we may want to try separating or just doing it in one operation. But for now, the numbers are small enough that writing them out is fine. 256. So we got 256 plus 196. 256 plus 196. That's only 452, which the 729 was what we were comparing this to. 729 is bigger. So our c squared is bigger than a squared plus b squared. That's an obtuse triangle. Okay, that's obtuse. We're going to try these. We're going to try these other ones in class together, and we'll see what we come up with, what we can classify these as. But in each case, we want to be labeling them A, B, and C, where C is our biggest side. First, check to see if the three sides can even form a right triangle, and then square all the sides and compare C squared to A squared plus B squared to see what kind of triangle. Okay, so we'll try those in class when we meet together. I'll talk to you later. Bye for now.